Hi everyone, my name is Luyang. So I'm a current PhD student at Carnegie Mellon, and I'm very fortunate to be here to have this opportunity to present our paper. This paper has been a joint work between me and Cassie Zhang and Baby Li and Chen Sheng. So this is a joint work between Samuel Hines and the CS School, Language Technologies Institute. So the paper is available on arXiv. We also submitted to NeurIPS this year. The paper's title is Fairshare data pricing while data valuation for large language models. And the very first question they want to ask is about why pricing data matters for the LM. And you can see the reasons could be major. The first major reason is that it's basically very demanding from leading LM builders. We can see that currently, in internet, there has been a limited amount of free scrap data, so say from Wikipedia and Stock Exchange. Basically, every model has been using that. And second thing is about legal risk and regulation. So last year we saw this kind of major lawsuit from Dow Jones against the Perplexity, which is another a search engine. So basically, using the data is very risky right now, and you have to obtain some license right now, and otherwise you face lawsuit. And third reason is that right now the leading companies there has been a demanding need for high quality label and domestic specific data, as previous presenters also established this kind of common sense. So here comes the key takeaways. So the model performance is basically driven right now. And we can see the architectures of large language models are basically very similar, so always transform based. And we can see the key differentiator is annotated data and how we obtain the data and what's the quality of data really matters right now. However, in this data market, there has been many challenges right now. First is that we can see that even though a lot of researchers are devoting to this area, we can see that in the current market, the price mechanism is very blurred and it's not very clear. So there has been an absence of transparent pricing. And second is that we can see that if you search internet, there's basically no disclosure from those leading builders about how they obtain data, or the disclosure is very minimal. And the second thing is that there has been no systematic pricing model for LM. Everyone is still kind of exploring. There's not a golden standard. And from the supply side, we can see that the work exploration is very severe right now. And the payment to the data annotators is very minimal, not comparable to the potential business potential or business value that their data has contributed to their models. And there has been a lot of lawsuits and discussions, and also the news report right now. For this Time magazine, they have this kind of interview revealing that OpenAI they hire the Kenyan workers very minimum hourly wages. And even for the entire AI industry, there has been 6 minutes interview, and they interview Kenyan workers, activists, and saying that basically it's a new age of slavery. So we can see that the problem is very major and very severe, and that's the drive for us to solve this problem. And also there has been some great work. Of course, it has been done a couple months ago, so maybe there's emerging new papers right now. So sorry, please forgive me not to include all of them. And the data pricing has been kind of emerging topics in the recent years, and there has been an old paper that they proposed a framework for pricing dataset, but not primarily for machine learning. And second, there's also been some mechanism design paper as well about how we can do this allocation of data to different companies. And third one is that how we can quantify the contributions. So this involves two main line of research, particularly in NLP community. The first one is gradient-based method, and second one is Shapley-based value-based method. So here's our framework. So we have a list of builders denoted by BK. We have a list of sellers, data annotators. So basically, set up the prices by anticipate the buyer's reaction, each with the data set DJ. So in our model, we assume that Stockberg and the sellers are the leaders. They anticipate the movement of the builders' buyers. And also, we have the kind of utility function as well. So basically, utility UK is just economic value as a function of model performance improvement depending on different tasks. So sometimes the mapping could be linear. So the better accuracy can lead to some increase of downstream values, but sometimes it could piecewise. So it really depends on different tasks. And the good news is our framework is basically very general, so it can incorporate most of cases or many of cases. The last component is data valuation method. So we assume that it's used by both buyers and sellers to evaluate the true value of annotated data. And as we mentioned earlier, there are two main strings of research direction. The first is gradient-based method, influence functions, which is a very major like research line, and leave one out, gradient tracking, also Shapley-based method as well. So basically, both of them have been used in many like ML or NLP papers, as you can see. And the good news, of course, is that our framework is very like method agnostic. So it basically fit any data evaluation method, does not change our main argument. So here's comes the structure of our market. So you can see that, oh yeah, here. So the data annotators, sellers, they basically annotate, each of them gonna annotate their own data. So mostly the cost is labor cost. And they're gonna sell the data to the builders, which each own like large language models. So maybe like in practice, like some of them own multiple, but here we just assume for simplicity that each of them own one. And the data can increase model performance, and which in return is gonna contribute some utility functions into the builders, which is mostly like an economic value. And you can see the price is based on two components, like M theory as we have just talked about, and also the data evaluation method. And here comes the exact form of our objectives. So first we discuss the buyer's objectives. So it's the buyer's decision-making problems is that they're gonna maximize the like profit. We can see here is the utility minus the total cost they're gonna pay, which is pretty straightforward. And the only thing we have to notice is actually they have a budget constraint. So I think that's kind of practical in industry. The second thing is the seller's objective. As we see that discussed earlier, that the sellers is basically they're gonna anticipate the movement of buyers. So it's a binary function that saying that given price PJ, whether the buyer BK is gonna purchase data as a DJ or not. And the total revenue or the profit is just the aggregation among all the buyers minus the cost, because data, once you create data, is always there, so we assume the cost is always fixed. Here's the seller's decision-making problem, the profit maximization. Again, it's pretty straightforward, and the only constraint we have is that the profit has to be not negative, otherwise the sellers will not participate in this market. Here's comes the main argument one we have in our paper. What is the exact form of this optimal solution? So here is more explanation. And we can see the right-hand side here is basically we define as each buyer's maximum willingness to pay, depending on two things. The first thing is the delta UK is basically the marginal utility that each data set can contribute to the buyer. And second thing is the marginal like budget. What is the remaining budget that the buyer can afford? And basically the maximum willingness to pay is the minimum of them. And for sellers, the optimal price is actually iterates over all buyers. And the one that gives the most profit is the optimal solution. And to have a more concrete like idea of what is the plotting look like, so we simulate a market of like two buyers and two sellers. So this graph is a profit function over different prices. And we can see that the first one is the seller's S1's profit over price. And we can see that it's a piecewise function. And we can see the two dot lines here are seller's one's profit, the buyer's one's maximum to pay and buyer's two's maximum to pay. And the optimum price is actually the buyer's one's MWP. And here is the profit function for seller two. And we can see the optimum price is actually the buyer's two's WMP or MWP. And the next question we have is that, okay, so we can see that the framework is designed for maximum the surplus or welfare for the sellers, but why buyers have the incentive to take this framework? So here comes our reasoning argument, is that sellers might quit the market if they receive unfair compensation. And this has been supported in many other previous economic markets, not in LM, because LM is still like very emergent. And so in our paper, we have this theory proof that in long term, our fair share price is actually always optimal for both buyers and sellers, because it's gonna promote the participation of the sellers in the market in long term, and it's gonna keep the sellers to stay in the market, and which in turn is gonna maximize the buyer's long-term welfare. So we also have one more simple simulations to see that with time growth, we can see that the buyer's optimal price is going to converge to our seller's optimal price eventually. So we can observe that in the beginning, of course, I mean, the buyers always want to exploit the sellers, but with time grow, and we can see that eventually they're going to converge together. And the last part is our experiment setups. And we have done some experiments manning the simulations. So we have buyer's model, 3 different models, Llama, Pythia 1B, Pythia 410 million. And we have like different sellers in different tasks. So we have math problems, medical diagnosis, and physical reasoning. So they are basically all the benchmark data sets and tasks that people use in NLP community. And we have 2 experiments. The first is the model performance improvement given different budgets and using different data evaluation methods. So the first experiment is going to prove that if the effectiveness of using data evaluation method in our framework. And second experiment is that, okay, so we simulate the market, what will be the buyer and seller gain over time using different pricing methods, which to show that our optimal pricing method works in this simulated market. And we have the experiment 1. So we can see that we have 4 different groups, INF-IP and BM25. They are both very popular data evaluation method. And we have random and constant, just giving the random data evaluation and constant data evaluation results. So we can see the first 3 plots we have here are always based on Llama 1B model, and they have 3 different tasks. So we can see that with the budget increases, the accuracy or the model performances of different like tasks also increases. And in the second plot, we can see here is that using data evaluation method can always give higher prices to the sellers, can give higher welfare to the sellers. And in the second experiment, which we simulate the data market, we have 2 different buyers, the buyers with a high budget and buyer with a low budget. You can see it's pretty surprising that buyer with a high budget, actually they can benefit the most using the Fairshare pricing method we have. So we can see there are 4 groups. So we have Fairshare, which is ours, reduced, which means that they have a discounted prices of the Fairshare. We have random give, so basically the buyer's gonna give the random prices to sellers, and current. Current means the current exploited price, which means that the price is very low. And we can see that the current pricing mechanism we have observed in the market is gonna damage the welfare for buyers and for sellers as well. And for the second plot, we can see the low budget buyers, the trade-off point takes later. And for seller's profit, we can see that, of course, I mean, it's pretty obvious in our framework that the Fairshare always gives them the highest or the most welfare. And the reason why is that the sales participation over time is going to decrease a lot using different or exploited pricing. And this is the last plot we have here. And also it further explains why the other pricing mechanisms always damage the buyer in the long term. So we can see that with high budget buyer, the Fairshare price maintaining this level. And with other pricing mechanism, we can see that the welfare of buyers decreases, and this is for low budget buyer. The reason we can observe something different is that low budget buyer, they don't care about the Fairshare price that much, is because their budget is pretty low. So basically that even though I promote the maximum participation of sellers, I mean, in the long term, I'm gonna not take the benefit of them the most. So that's the reason why you can see some like separation of them both. So yeah, that's then the presentation. Thank you so much, and I'm happy to solve any questions we have. Please stop.
Mic, or can I just speak out? Okay. So quick point is, there's considerable asymmetric information in the setup between the people who are doing the annotation and the developers of the large language models. So if you go back to your slides, the way you set up that market, I don't. Yeah, I think that we have to kind of model maybe an additional parameter.
Oh yeah. I think that's a great question. So basically, we essentially talk about the difference between like full information and partial information. I think that's a great question. Also, we received a lot from the reviewers. So basically, what we assume here is that we are kind of the very first batch of people doing that. And we believe that the full information provides a very good benchmark. You can see that what's the cost between the full information and partial information, and that's a good follow-up. So we're gonna continue to pursue that. So our intuition is that with the partial information, and it's very important to have this kind of transparency as the previous speaker has. So our insight is that with more transparent policies, actually it's going to benefit both parties. And I think that's a good follow-up. But thanks so much for the question. Yeah.
So I have a related question on perhaps things that are missing or could be added to the model. Yeah. So I've had a few interactions with one of these data sellers. I'm working closely with them on something. And so this company was started in January, is making over $1 million a month right now in like 6 months of getting started because the appetite for data is so high. And so the two things they mentioned, which I'm not sure I'm seeing it in this. One is some contracts are where you sell the same data to all the LLMs, and some where the LLMs are saying we want exclusive access to this data and you have to pay to eliminate it from the market. So the ability to have exclusive contracts. And the second one is they were saying they pay about $50 an hour to their annotators because their annotators are knowledge workers. So it's a bit different from the Kenya scenario. It's a bit more of like consultants, data analysts, coders, annotating knowledge work type of tasks. And so I guess there's an element to perhaps the how scarce is the skill set of the annotator as well?
Yeah, I think those are great questions. So in terms of first question, like exclusive and like exclusive, so basically we also consider that. And we believe that in our framework, basically everything is non-exclusive, so you can repeat itself to others. But we believe that exclusive is also very important, like scenario, like in the current market, because like companies want to take seize opportunities and say, okay, the data is mine. If you purchase your data, the same data, maybe my edge is gone. So I think that's a great extension and follow-up based on this model. And second question, in terms of what you just described, I think that's also very interesting, like scenarios. So actually, we're conducting some experiments right now. We are trying to reduce some circuits and giving them different payment to see if different payment actually incentives different quality of data. So we can see that if like higher payments gonna incentive like better quality of data, can give better model performances. I think they're also very interesting follow-ups we can do. But I believe that yes, of course, I mean all the insights are correct because only like maybe the people with high advantage of like knowledge or higher education, maybe they can create a better data set and can contribute to the complex tasks we have right now for MLs. Yeah. So thank you so much.
Well, thank you very much for